Hello and welcome to AWS On Air. I'm Steve Roberts, a developer advocate for .NET and PowerShell at AWS. And today I'm joined by Jeff Barr. Jeff, how's it going? Do you want to
Hey,
introduce
Steve,
yourself?
great to see you. I'm Jeff Barr. I am VP and Chief Evangelist for AWS.
Cool. So today we're not talking about a new launch as such. What we're going to do is actually summarize all the great enhancements and new features in EC2 over the last few months. And to do that, we're joined by JD Koos. Welcome, JD. Would you like to go ahead and introduce yourself and tell our audience a little bit about what you do at AWS?
Sure. Yeah. Thank you guys for having me on. This is really nice. So I'm in the EC2 product team, and I have responsibility in the team for basically what we call our x86 instances. So I have some peers on the team who own our Graviton instances, and some of our accelerated instances. But my responsibility is really to own all of the kind of marketing and a lot of the launch and positioning and use cases associated with x86 based EC2 instances. But today I'll be talking about not just those instances, but kind of all of the what's going on with EC2.
And there's quite a lot to talk about. So I guess we should probably get started by first maybe talking about, what are the big focus areas for EC2 these days?
Yeah, we're really thinking in a few categories. We try to have a picture of where we're trying to innovate for customers, and I would kind of lump it into like three big categories. First one being within performance. So within performance, a couple of big ways. Number one is giving customers better performance on the existing instances that they are running today, as well as increasing performance with new products. And I say not just instances, but new kind of technologies that are being introduced. And we'll talk, I think, more about those maybe in a bit. Another big area that we're focusing on is security. You may have seen this, but with all of the instances actually that have launched in the last 6 months, all of the 6th generation instances, just about every single one of them comes with always-on encryption. And so that goes for the Graviton-based, the AMD-based, as well as the Intel-based instances. The third big bucket, if you will, for where we're focused on EC2 is to give customers more options so that they can really optimize their applications for really specific workloads on specific compute that really fits those workloads the best. So those are the big three areas.
So, JD, having blogged about so many of these options over the last many years, I'm still curious. How do we actually go about deciding what options we should offer to our customers?
Well, you know this, Jeff, and I think we all get to do this. Fortunately, it's great. So we're regularly engaging with customers, talking with small to large customers, and we are able to understand from them that it's just a massive number of applications from homegrown to ISV that they want to run. And so they really need compute resources or say instances specifically in the way we talk about them, not just with varying compute, storage, networking, and memory. But nowadays, what we're hearing is, and we've known this for a while, but it's just more and more so the case over time, that it's specific engines or specific accelerators for things like machine learning, both on the inferencing and the training side is what we're hearing. There's graphics intensive workloads that customers want to run in the cloud, and they want to do custom tasks. We enable customers there with FPGAs in our instances. And we've also heard that customers have certain use cases, certain reasons why they want to continue to run some workloads on bare metal in non-virtualized areas where they have direct access to the hardware. So today they're actually over 40. I think we're just about to push 50 EC2 instances that are bare metal instances. So we get that feedback from customers regularly, and it's driving our focus on the big three areas: performance, security, and increasing the breadth of the compute options.
Okay, so let's focus in on each of those areas. So, what specifically are we doing for performance?
Yeah, performance it's a pretty long list. If we were to go through all of it, I don't think we could complete it in one of these sessions, but there are a couple areas that I think are big chunky areas worth kind of summarizing. The first in performance is what we're doing with AWS Nitro system. So we've been talking about this for a few years now, that Nitro system was truly generally available in 2017. And it has multiple components to this system, but we're continuously tuning performance, not just in the hypervisor, but also what we offload and how we offload onto the Nitro IO card, as well as the security chip. In fact, I do want to share one slide. I'm not going to share any other slides except for just one, but I'm going to show one slide that is like a really cool performance slide that I think benefits from a little bit of a visual. So I'm going to take 1 second and try to pull that up. Give me just a second. If I go to share, I'll bring that one up. Can you see that? I think I may have gotten dark for a second. But if you can see that slide, so what we have here is basically, if you look on the left, what we've done is taken three different options, basically looking at infrastructure as a service from AWS, that is EC2, and then comparing that to vendor A and vendor B, two different good options out there for infrastructure as a service. And you look at the spec GIMP 2017, and that's our way of demonstrating that these are like for like, apples to apples comparisons with the same processors, Latin, and the same memory and same IO footprint. So spec GIMP is just ringing out that CPU performance, and so you're going to see the exact same performance. But then when you look at real world application deltas, you're actually seeing significant differences between EC2 and what you're going to see on alternative options out there. Not going to present each of these metrics in detail because you can really see it on the slide, but I would say that this is just 3 out of a number that we have observed, and these numbers are slowly getting better and better over time. We're not the only ones continuing to innovate. Everyone else who's making infrastructure services as well, but certain benefits of the Nitro system and owning that hypervisor have allowed us to have this advantage and then to continue to drive more and more innovation. So this allows customers to really have direct access to the compute resources of EC2 and therefore the better performance. So that's really what's going on with the Nitro system specifically. And if I can bring that slide down, then there are a couple of other areas in performance to talk about. But I would say to summarize with Nitro system, it really is its hypervisor, it's the offloads that we do onto the IO card, as well as security, because security tasks can actually, and in the past, have been a big tax on the host processor, but what we do for offloads really benefits a lot in terms of customers' instances that run.
I continue to be impressed by all the cool work that we're doing with the Nitro system and how the definition actually continues to expand. So just a couple of weeks ago, JD, we had a guest that we talked about the AWS Nitro SSDs. Tell me a bit more about what we're doing for our customers that have very low latency requirements for the workloads.
Yeah, this is an area that it's been years in the making, let's say, and I'm super excited to have been part of this and helped us bring this out a bit last year. The Nitro SSD is, it's one piece of technology, but I want to think about it, and I want everyone generally to think about it from an application perspective. So think of MySQL or like Oracle Database, MongoDB, Aerospike, Couchbase, or Redis, just a long list of applications that really benefit and really need IOPS and need them to come in with predictable latency. So we launched 2 instances at reInvent last year, and we're just in the process now of launching a 3rd instance that support this new AWS Nitro SSD. So the Nitro SSD, I think, to summarize it, it's AWS designed silicon as well as innovation in the flash translation layer, or the FTL, as normally we call it. And we've made that available, as I said, in 3 different instances now: the IM4GN, the IS4GN, and the I4I instances. So 12 total options for Graviton, 2 processors, and then 7 that have 3rd generation Intel Xeon Scalable. So that's the why and the where and the use cases and really the applications that customers have wanted better performance and lower latency so that they could bring it into the cloud. So what are we seeing? Benchmark results, which you put so much weight behind benchmark results, but 60% lower IO latency for storage, and then 75% lower IO latency variability. Really, really important. Now, those could be corner cases, so we don't spend too much time, obviously, on the benchmarks, but what are customers seeing? There's a number of customers who have been testing on these instances and are deploying today. I don't have the ability to share all of the results, but I can share with what we've seen from Redis. Has come back and told us it was a 2.9x increase in query throughput when they compared to the previous generation i3 instance. So 2.9x is just amazing. It's been really great to see them do that testing and then have customers that use Redis as well benefiting. SkyliDB, it was very similar. They use a slightly different way that they measure their performance, but 2.7x increase in the throughput per vCPU. So this Nitro SSD, it's been a lot of fun in the last few months, finally rolling this out to customers and giving them, both internally, it's fun to do the testing and seeing what customers are able to do in terms of just ringing out really great performance.
Yeah, those are some pretty mind-blowing numbers.
Yeah, I just kind of throw them out there like 2.9x, but like, well, that's almost 3x, right?
It's a lot.
So I hear on the grapevine that we've also been making network performance improvements. So what can you tell us there?
Yeah, it's an area that I think, sometimes I know some people think networking is boring. It can be a bit difficult in certain areas. There's a lot to it. Many customers have told us really over the last couple of years that their clusters that require high networking speed between the nodes, as well as applications that need to support very high packet rates, packet per second rates. Those, and those might be ones obviously with small packet sizes on average, right? Where they really have high packet per second rate needs. It's not just about the bandwidth. Those don't run in the cloud and haven't run in the cloud, whether it's EC2 or really anywhere else. And they've been a challenge to get those into the cloud. So I can summarize in saying that the latest generation of general purpose, the memory optimized and the compute optimized instances that we've launched just in the last 4 or 5 months, all more than doubled their networking performance from around 20 on the storage side to 20, from being 25 on the networking side, up to now 50 gigabits of networking bandwidth for general purpose networking speeds. And then 40 gigabits now is there to what we call the Amazon Elastic Block Store. That's remote block level storage for EC2. And that's just the standard instances. So compute optimized, memory optimized, and general purpose ones, where you have AMD and Intel as your choices for x86 processors. Now, if you look at the accelerated instances where people are running FPGAs and ASICs and GPUs, in our fastest one, the P4D, we actually support up to 400 gigabits of networking speed that customers are really enjoying having that today. And that actually is the fastest speed networking from an Ethernet standpoint that is available in the cloud today. There's also a number of instances in the last few months that we've launched that have 80 gigabits now. From 19 gigabits used to be the top. We're all the way up to now 40 gigabits of throughput to the remote block storage, that's EBS. And then packet performance, it's also continuing to increase. And you're going to see us continue to invest on packet per second improvements with some really cool innovations this year. So, I mean, I guess I could summarize in terms of performance. I know we talked about a lot there, but the 3 big things for performance, if I could summarize, is it's the Nitro system tuning that we're working on. And then it's finally enabling what used to be kind of stuck on-prem workloads for low latency storage IO, allowing customers to then successfully and very efficiently bring those into the cloud with instances that use the AWS Nitro SSD, and then enabling workloads that need higher speed IO, both for general purpose networking capability and then higher speed storage access. So those are big 3 performance kind of buckets.
I love how you put like big numbers into it. You just drop them in like Jeff just mentioned, and then you go on to say, and then we have the accelerated versions. And I'm thinking, how fast can it go?
And I was just thinking that it was not that long ago that when we were talking about bandwidth, that it was tens of megabits and then low hundreds. That was so we're 1,000 times better than we were just a few generations ago.
Yeah, and I've only been on the team a handful of years, but yeah, it's great to see that these improvements really are happening very quickly. We've been busy. Everyone's been busy. You guys are participating in this.
Of course. So you dropped a little hint earlier about some of the security features that are enabled by various parts of the Nitro system. But what are some of the newer things that we're doing in that space?
Yeah, I think this is really important, and I should mention, this is obviously we're just talking about what's new and what's happened recently with EC2, but over the course of years, security has been very important and continues to be for EC2 and for instances specifically. And with things like Nitro Enclaves, the Nitro security chip, lots of very strong capabilities and technologies, features that really are there. But lately, just in the last few months, you've seen us, or we've launched our 6th generation instances all the way across Graviton, AMD and Intel based instances. And actually all of them today now support basically by default full encryption. It's carried out in slightly different ways. And we actually started this with our Graviton 2 as the host processor, or instances that use Graviton 2. And so we've extended that for the Intel instances that use the total memory encryption, which is an Intel feature that has to be enabled. We call that TME. And then on the instances that use AMD's third generation EPYC processors, like the C6A, M6A, and the HPC6A, with more to come there, we also support this feature called transparent single key memory encryption. So that again is always on memory encryption without a performance penalty there. I think the other thing to mention that we've announced that is not generally available today, but coming soon this year, is the Graviton 3, what's happening with Graviton 3. So as we roll from Graviton 2 to Graviton 3, and we start doing that this year, as we first launch the C7G instances, which have been announced and are in preview, but our goal is to raise the bar even further on instance level security. And so we'll, in addition to supporting the always on encryption, we'll support dedicated caches for each vCPU, and then pointer authentication, two kind of very significant features that are coming for C7G. So these are now, as I said, the default always on encryption, and it is available across all 6th generation EC2 instances, whether you're talking AMD, Graviton, or Intel powered.
I always love to dive deep on architectural things deep inside CPUs, and the pointer authentication is actually really, really cool, and looking forward to seeing that get into widespread use.
Yeah, I think so. And our team's really, we want to enable this kind of technology, obviously not just for Graviton, but we want to enable it all the way across the board. So definitely a lot of work to be done there.
Yeah. So you said another area the team's focused on is on bringing more compute options for customers. So, I mean, what does that look like?
Yeah, this is an area where it's funny. It keeps me busy when it comes to how many new instances, just the raw number of actual new instances that we're bringing out. And we've talked about this a bit before. It's something we regularly sort of share is when we brought out the Nitro system in 2017, it allowed us for just an increase in the rate of bringing out new options for customers. So, and there's some slides that show that where all of a sudden it hits the hockey stick and it kind of goes up in 2017. But just in the last 6 months, as you can see, we've launched almost 100 instances just since the fall of last year. And now there are 513 instances as of a couple of weeks ago total that are GA. And that's more than any other infrastructure as a service cloud provider out there. And I was going to say, so this is something that I'm in my day job kind of working on, is bringing out a lot of the documentation on these new instances and a lot of the positioning and the use cases that we're targeting. And so we're not going to go into the detail with every single instance as far as adding to the breadth, but summarizing a little bit. So we've launched, this is kind of where you get the big long list of instances, but compute optimized, general purpose, and then dedicated HPC specific instances. We've launched all of those with AMD's 3rd generation EPYC, known as Milan processors, just in the last few months. We've also launched compute optimized, memory optimized, storage optimized, and general purpose instances, all in the last 6 months, that are supporting Intel's 3rd generation scalable, or Xeon scalable processors. So that's really like just a summary of the kind of general set of new instances that have happened in the last few months. There are some more specific use cases, but that we call those the general purpose compute optimized, memory optimized, storage optimized instances. But they're even more than that.
So you mentioned special use cases. I mean, are there any examples of applications that customers can run now that they couldn't before?
Yeah, there definitely are. When you look at like specific use cases like video transcoding, this is one that's come up with customers in the last few months, or say years it's been in process, but now that we have it generally available, customers are realizing how valuable it can be to have very dedicated ASICs for video transcoding. So we launched an instance there called VT1 last fall. That has seen really good, I would say a lot of customers excited to use that new instance. And that was not a use case really that could be done in our cloud before, And we've also just in the last couple of weeks launched the new X2 generation of instances. So that's X2 IDN, X2 IEDN. Sorry for the mouthful on those, but there's kind of a reason why they have those big long names. But those instances, they support up to 32 gigabytes of memory per vCPU. So a lot of memory per vCPU. So they're designed for production deployments really of in-memory databases such as Redis or SAP HANA, as well as they are being used for in-memory analytics like what SAS does and what Aerospike does. So those are being run on the X2 IDN and X2 IEDN instances. And those are not use cases that I think in the past people really associated with running in the cloud. You know, when you're going to run SAP HANA in the cloud, you really can do that today. Another area that's like a net new for us use case, or getting very focused on use cases that we enabled, is with the X2 IEZN instances. And they use, it's a partnership with us and Intel there, where we use what we say, and obviously had to work on this to make sure it was true, is the fastest Intel Xeon scalable processors. That's up to 4.5 gigahertz. That's an all-core turbo on that. And those instances also have 32-to-1 memory and 100 gigabit networking, but they're designed specifically for EDA workloads. So they work really, really well for EDA workloads. I won't go through each customer quote and what every customer has seen, but the list is long. It's Cadence, it's Siemens, it's NXP, Annapurna, our own Annapurna Labs, Synopsys. We've all tested the X2 IEZN, compared that to our previous generation instances, as well as what they were doing on-prem, and the performance results are really great for a lot of
this is just amazing. I mean, there's just so much to talk about, and we've effectively kind of run out of time, so we're going to have to end it there. But you know, thank you so much to JD for joining us. That was just great. I hadn't realized there was so much going on with EC2. So, and I even work in EC2, so you know. So yeah, that's great. Thank you, JD. Much appreciated.
Good, awesome. I really appreciate you guys letting me come. Happy to come back if we can spare more time. I'm sure 6 months from now there'll be another long list, right?